Hi, I'm Chris. In this video I show you how to sketch a table lamp in 3-point perspective. Enjoy! Before we dive into the process of sketching, let's have a look at what I'm going to sketch, or rather said, what I use as a design reference. And that is the AJ table light. The AJ table light was designed in the 1950s by the Danish architect and designer Arne Jacobsen. It is of a really minimalistic design, so egg-shaped base with a circular cutout, a slender sloping stem, and a visor-like lampshade. From geometry point of view, all these elements somehow can be described by or simplified to basic geometrical elements. And that is something we make use of when we rebuild the geometry on paper. And now let's get started with chapter number 1, building the frame. So I do start with a base and I simplify the egg shape of the base just to a plain surface with rectangular boundary. The view I'm sketching is similar to the one of the picture I showed before. 3/4 view, slightly looking from top on the lamp. As consequence, the short boundary lines of the surface are representing the width of the base and convert to vanishing point 1. And the long boundary lines are representing the length of the base and convert to another vanishing point 2. What I sketch next is some support structure for the stem and the shade. Again, I make use of a plain surface with a rectangular outline. This time I place it on top, perpendicular and center to the base. And by doing so I'm creating two things. First, a reference for the position of the stem and the shade relative to the base in width direction. And second, a third dimension which I use as reference for the height of the lamp. This third dimension comes with a third vanishing point those vertical boundaries of my surface are converting to. I use that surface to sketch further supportive references. First is another reference line which I position approximately on 2/3 of the total height. This line represents the lowest level of the shade. Second is the axis of the shade, rather said the axis of the cylindrical part of the shade. And third is the axis of the cylindrical cutout in the base, which is roughly coincident with the axis of the circular boundary of the shade's conic part. So, I end this chapter with a grid of support planes, lines and axes. This is the support frame for the next steps. Chapter number 2, going into detail. I start with the axis of the stem, which I place perpendicular to the base. That means it is running in vertical direction, and due to that it is pointing at the third vanishing point. After that I focus on detailing the shade. I do start with the cylindrical part, that part which is connected to the stem. From geometry point of view, the cylinder does have a constant circular profile, and this circular profile of the start and the end of the cylinder I sketch first. Since we are looking from an angle view on the cylinder, its profile is not appearing as circle. Instead, it appears as ellipse, and that is what I'm sketching here. Next is the circular boundary of the conic shaped part of the shade. Same as described before, from our spectator's point of view, the circular profile appears as an ellipse. Center of the ellipse is the intersection point of the vertical support axis and the horizontal reference line. Once the circle profiles are sketched, I add contour lines, starting with the cylinder, then heading over to the conic shape. Just putting a bit of line weight to the visible boundary line of the conic part of the shade generates a further 3-dimensional appearance of the complete shade. Moving on with detailing the lamp's base. I start with an offset of the existing rectangular plane surface, which I draw in the first chapter. By that I add a third dimension to the base and I generate a first impression of thickness. Then I project the circular boundary of the shade on my upper rectangular surface. The ellipse is slightly more open than the one of the shade, simply because it's positioned even lower beneath our eye level. Next to that ellipse, I sketch a second one. It is a bit smaller and concentric to the stem. Once I have this pair of big and small ellipses in right position and proportion, I sketch a second pair of ellipses with same proportions and dimensions on the lower rectangular support surface. Big one first, smaller one second. So I end up with two really short cylinders, one with bigger, one with smaller diameter. And now comes the trick to illustrate the X shape of the base. I connect those ellipses with bended curves and a tangential transition. That means those curves do not intersect the ellipses, instead their curvature smoothly adapts to the curvature of the ellipses. Having now the first egg contour on that top layer, I repeat the same procedure on that lower level. I ignore those areas which are hidden by the geometry and just focus on the visible edges. Just adding a bit of line weight on those visible edges and those lines I want to put emphasis on. And there we are with the egg-shaped base. I move over to the stem. The geometry of the stem is more or less a cylinder with a small diameter compared to its length, or in our case height. To sketch the contour lines of its shape, I use the already sketched axis as orientation reference. The little ellipse I'm sketching on the lower side here is showing the stem's circular profile as it is connected to the flat surface of the base. What I overlooked when sketching the base was the cutout, so I will do it now. The circular cutout is positioned in the middle of the bulbous part of the egg-shaped base. That means I sketch once again an ellipse with my support axis in its center. I try to keep it a bit smaller than the big ellipses I sketched before to show that there is some wall thickness left. It is getting a bit messy here, many ellipses as construction lines, but that's not a problem. I simply put line weight to the one which is looking right and I want to put emphasis on. So fully visible edge on the top side is done, so same procedure on the lower level. The edge on bottom side is mainly hidden, but the area we do see from our viewing angle, I add line weight to. And yeah, there we are. The AJ table light is visible as a three-dimensional object, but it is still looking like a grid of lines. And that is leading us to the third and final chapter, creating depth and volume. My aim is to add a bit more information to my sketch with regard to the shape of the lamp surfaces. To do so, I will add light and shadow to my sketch. What I need for that is a light source in defined position relative to the lamp. Surfaces of the lamp turned to that light source will be bright, surfaces turned away from the light source will be more dark. Starting again with the lampshade. I choose to place my light source in the lamp's background, illuminating the lamp a bit from top. Following the principle of defining bright and dark areas, I start with shading those surfaces of a lampshade which are turned away from the light source. I use hatching, a shading method where lines are placed next to each other. The closer and thicker these lines are, the darker the hatched surfaces appear. The visible surfaces of the lampshade are not flat, they are bended. To illustrate that in my hatching, I'm looking for a smooth transition from thick and narrow lines to light and less narrow lines. The same principle I use to shade the base. I start with the vertical surface of the cylindrical cutout, which is a bended surface as well. Starting from the darkest spot, I move slightly forward to the brightest spot. While doing so, I'm aiming for a smooth transition in my hatching. Same with the outer vertical surfaces of the egg-shaped base. As you can see, once I went from dark to bright, I repeat that process. It's like an iteration process of doubling the hatching until I reach the gradient and shade I'm looking for. To add even a bit more shape information to my sketch, I add section lines. Imagine you take a plane, you move that plane through the object and cut the object by that plane at several positions. Where each cut is made will be a section line, and this section line will follow the shape of the cutted object at exactly this position. For those section lines I'm sketching on that lampshade, I'm using imaginary planes which are positioned perpendicular to the length axis. Same principle to add those section lines to the base. The first imaginary plane is perpendicular to the width axis. That means it is rotated by 90 degrees compared to the planes I used before. The second imaginary plane is perpendicular to the length axis. That means it is parallel to the planes I used before to cut the lampshade. Well, and there we are. We crossed the finish line of this follow-along tutorial of sketching the AJ table light. If you made it until here, thanks for watching. You are interested in similar videos of mine? On left side you find the preview of my previous tutorial. On the right side you find one of my videos YouTube assumes is best for you. See you next time.